Your FastMCP server is running, but how do you lock it down so only authorized clients can access your tools? We'll implement JWT verification using public key cryptography to ensure every request is authenticated before your server processes a single dice roll. You'll see exactly how to configure the verifier and attach it to your FastMCP instance. No shared secrets, just cryptographically signed tokens. From FastMCP, import FastMCP. From FastMCP server auth import JWTVerifier. Auth equals JWTVerifier. Public key equals key pair, public key. Audience equals dice server. MCP equals FastMCP. Name equals dice roller. Auth equals auth. This demonstrates the authenticated RPC gateway pattern, where a server exposes specific functions as remote tools while enforcing access control. The pattern combines RPC, remote procedure call, with JWT-based authentication, creating a secure bridge between external systems and your backend logic. What makes this distinctive is the separation of tool definition from security concerns, handled through composition rather than inheritance. The pattern works by layering authentication at the server level, then exposing decorated functions as discrete tools. The JWT verifier acts as middleware, validating requests before they reach your business logic, while the @MCP tool decorator maintains clean separation between interface and implementation. This design keeps security concerns orthogonal to tool logic, allowing you to modify authentication without touching your core functions. This approach solves the dual problems of secure exposure and clean architecture. It's particularly valuable when integrating with third-party systems like AI APIs that need controlled access to your functions. The trade-off is slightly more upfront configuration for authentication, but you gain a maintainable system where security policies and business logic evolve independently. Use this when you need to expose internal functions securely without coupling them to transport or auth details. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core class for building AI-callable tools. It transforms Python functions into structured APIs that AI models can invoke, handling serialization, validation, and transport automatically. From FastMCP server auth import, JWTVerifier. This imports JWTVerifier, the authentication handler for FastMCP servers. It validates incoming JWT tokens, ensuring only authorized clients can call your tools. Auth equals JWTVerifier. This instantiates a JWT verifier for incoming requests. It validates tokens against the provided public key, ensuring only authenticated clients can access the MCP server. This is the standard auth pattern for FastMCP services. Public key equals key pair, public key. This passes the public key from an asymmetric key pair to the JWT verifier. Public keys validate token signatures without exposing private keys, ensuring secure authentication while preventing impersonation attacks. Audience equals dice server. This specifies the intended audience for JWT validation, ensuring only tokens issued for dice server are accepted. Prevents token reuse attacks by enforcing audience matching during verification. This closing parenthesis finalizes the JWT verifier instantiation, locking in the authentication configuration for the FastMCP server. Without it, the object remains incomplete, preventing proper JWT validation for incoming requests. MCP equals FastMCP. Name equals dice roller. Auth equals auth. This instantiates the FastMCP server with JWT authentication and a human-readable name. The name appears in AI tool listings, while the auth parameter enforces secure access to all registered tools. This is the standard initialization pattern for FastMCP servers. FastMCP JWT authentication. The JWTVerifier pattern shown here bridges Python functions and secure AI interactions, where tokens become both gatekeepers and connectors. The audience claim must exactly match between token creation and verification, or all requests silently fail with 401 errors. Always rotate development keys before production deployment, even when using temporary utilities like RSA key pair.
The token that carries no identity becomes the universal key.